And now we are moving into a different area where you are going to learn uh, what you call sectors. Okay, the circles of sectors, right? When it comes to the sectors, what is first of all a sector? So in this case, what we are going to talk about is sectors of a circle. Sectors, as the name means, sector is something like this. Now, previously what we learned is, now when it comes to the perimeter of this is equivalent to 2 pi r, right? So this is equivalent to the total length from this point to this point, right? If you recall, this is the total length from this particular point to this particular point, right? So if we consider like a ground in your school, right? So if you run from one point round it and come into the same point again, that is the perimeter or the circumference, I would say, of a circle, right? But when it comes to a sector, sector is not the complete circle that we are going to talk about, only a part of it, right? You take a portion like this, like, or if you have seen a pizza, so pizza is actually a piece of pizza would be a sector, right? So say that if you want to uh, find the length from here to here, so let's call this A and let's call this B, from here to here of a piece of pizza or slice of pizza. So in that case, how are we going to find this, right? So this is what we are going to learn when it comes to sectors. Now, when it comes to sectors or finding the length of sectors, the perimeter of sectors, we are going to focus on two things. First of all, there's a circling part or portion of a circle. That this is this portion, right? And there's a portion like this, the straight line portions like this. This is the other two portions, right? So as I mentioned, circle, a part of circle, we have a circlic portion, and or we call it arc, right? And we also have lengths like radius in here. So this is actually equivalent to the radius. This is the center of your circle, right? So how are we going to find this? Let's take the full circle, right? So when it comes to full circle, one thing that you have to remember is that when it comes to the angle of it, from this angle to here, what is this is actually your radius, right? Radius. From here to here, what is the total angle? That is actually 360 degrees. This is not something that you're going to get in your syllabus, but this is something that you can uh, learn at this point as well. From here to here, this is 360 that we know, right? So we are actually going to talk about the proportions of it, right? So when it comes to here, the for the full circle, the entire circle, we know the angle, the total angle from here to here is 360 degrees, right? So for 360 degrees, the radius is 2 pi r from here to here, right? So likewise, what if we want to find the distance of a of a, of a of an arc, right? So in that case, let's consider an arc like this, right? So and if we draw the entire circle of this arc, something like this. Now my circle shapes are not the best, but you can get the idea. So so as I mentioned, when it comes to this, the entire circle, the angle is 316 here. But when it comes to arc portion, it is just let's say 60 degrees, right? This is from 60 degrees. Now what you can see is the uh, the length of from this point to this point is proportional to the angle that you have in here, right? For example, if I take uh, something like this, this is 6, let's say this is 60 degrees, and the length of this is proportional to this angle, right? If I increase this into here, see, the length increases as well. So this is actually increasing proportionally when it comes to a circle. If I increase into this 90 degrees and this is say that 120, so the length is becoming the length of from here, this point to this point, right? So simply, what do you call, the length of this proportion is equivalent to the proportion of the degree, right? It means if it is 60 degrees, 60 degrees, so what is the formula of this? So what we are going to do is we have to, let's call this perimeter of arc. Let's put the value of a in here, right? So what you have to understand in here is that as I mentioned, this is proportional. So in that case, this is equivalent to a divided by 2 pi r. What I'm going to do is I'm going to divide this from this formula. So again, this is not in your syllabus per se, right? This is equivalent to 60 divided by 360, right? So a is equivalent to 60 divided by 360 into 2 pi r, right? 60 divided by 360 into 2 pi r. Now, if we now this is actually an example that we took, but if this is not 60, but instead of this is, let's call this as theta. So the formula that we are going to get is the perimeter of arc is equivalent to, instead of this 60, I'm going to put theta divided by 360 multiplied by 2 pi r. So this is the formula for arc. Arc meaning, so what you're going to get is the distance from this point to this point, right? This point to this point. Let's take another color from different one. Let's take green, right? So what you're going to get is distance from this to from here to here, right? Not this, not these arcs, but you're going to get the distance from the arc portion of A to B is equivalent to theta divided by 360 multiplied by 2 pi r. So this is the formula that you have to remember. Theta is whatever the angle that you are going to get inside this. Why? The reason is we know this is proportional to the length of arc is proportional to the angle in here, right? When the angle goes up, the length goes up. When the angle goes down, the length goes down. So likewise, so what you have to remember, as I mentioned, is this particular formula. So these the things that we have discussed earlier is not quite in your syllabus, but it is something that is valuable for you to learn. But this is sufficient. If you remember this particular part, it is sufficient. So just to summarize, let's remove all these and right. Let's remove all these and just to summarize, what we learned is that if we take an arc, right? What do you mean by an arc? Arc portion is equivalent to from this point to this point. As I mentioned, my drawings in here is not quite the drawings that uh, we are having in the circles or arcs. So this is, consider this as an arc portion. This is the radius, right? So this, if we make this circle a bigger one, I mean the complete one, so this the entire circle. would be something like this, right? So what we spoke about is this distance from here to here, A to B, right? From here to here. The arc portion, we call this arc portion. As I mentioned, this does not include this one. Arc portion from here to B, arc portion is equivalent to uh, theta divided by 360 multiplied by 2 pi r. The reason is this is proportion. So what we are trying to find out is what is the proportion of value uh, proportion to the entire circle, and we are going to figure out the arc portion, right? If theta is, for example, 360, meaning this is the entire circle that we are talking about. So 360 is 1 multiplied by 2 pi r, right? So we get 2 pi r. That is the perimeter or the circumference of the entire circle, right? So in that case, what you are going to get is this particular formula. This is something that is valuable for your exam. Again, if we consider the arc portion, right? How we are going to get theta divided by 360. This is the perimeter of entire circle, right? Let's quickly jump into a couple of examples now in here. So this is actually the summary that we spoke about. This is the formula that we figured out from the previous discussion, right? So in here, so you can see this is the angle of this from here to here. This is the radius, and what you are going to get from out of this formula is from here to here, right? So just these are a couple of special scenarios. So so it's okay if you even remember this by heart, but what you have to remember is now what is, first of all, what is our formula? Formula is arc is equivalent to theta divided by 360 multiplied by what 2 pi r, right? So if you are given 180, meaning that is actually in here, this theta becomes 180, right? To 2 pi r. So this actually, this is 1, this is 2. This particular portion becomes half. So that is what they are saying. So as I mentioned earlier, I don't quite recommend this, but it's okay if you want to remember these things now. But what the basic that you need to understand is, when it comes to from here to here, if you get a straight line inside the circle, this angle is 180, you can substitute straight away 180 in here. And if you get something like this is a right angle, this is 90 degrees. And if you get something like this, and this is the angle is actually given 120. I mean, if the angle is divided into equal three parts, that means as we mentioned earlier, the total angle is what you call 360. If it is divided into equal three parts, this becomes 120 degrees, right? Likewise, this portion, this is uh, 3 divided by 4 portion of it, right? 3/4 of it is equivalent to 270. So if you don't know the angle, that is theta, uh, theta divided by 360. So my recommendation, as I mentioned, my recommendation is stick into this particular formula. Formula is arc equivalent to theta divided by 360 multiplied by 2 pi r, right? So stick into this one, and you can figure the rest of the arc formations accordingly. But if it is too hard for you to stick into this one and figure out the specifics, you can remember, so if you get half a circle, what you have to do is the total circle's perimeter is this. If it is half a circle, you can multiply it by half. If you get 1/4 of a circle, what you can do is you can divide by 1/4. right? If you get 1/3 of it, you can divide by 1/3. Likewise, you can multiply accordingly, right? So far we learned about the arcs and the special formations. What if we get the special formations and all? And the next thing that we are going to do is we are going to try a couple of examples or exercises, right?